You're on a hot air balloon ride enjoying the sunset with your date. You have no idea what to say other than, "The moon looks so much bigger up here." She agrees, but says that sadly you're not bigger. "Well, hey Kyle, look, I'm huge!" And while your girlfriend is completely correct that you are indeed the smallest man I've ever seen, doesn't this view make you question what the true scale of the universe actually is? And is it even possible to visualize? Why don't I shrink down and together we can go into my new sensory deprivation tanks in order to accurately compare all object sizes in the universe from the smallest to the largest. See, scale is simply a matter of perspective, except in your case. So, let's begin with atoms before increasing the size to space objects. Look at that, Kyle and Kyle's date. It's an atom, a 10 billionth of a meter across. This is the building block of all matter in the universe. Everything you know of has millions and trillions of these. But did you know it's 99% empty space? Well, that's because the nucleus is 100,000 times smaller than the atom and sits at the center. And it's made up of the particles, protons, and neutrons. The nucleus is so dense that its very nature is how stars, galaxies, and the entire universe is powered. Additionally, when you combine atoms, Kyle, you get molecules. This is where chemistry lives, because it damn well didn't exist in that hot air balloon on your date. Am I right, miss? Oh, you have chemistry with me? Well then, let me carry on showing you the scale of the universe and impress you with my massive brain. Don't worry, we'll be in space before you know it, Kyle. After molecules start stacking and stacking, we get to proteins and DNA and gooey biology stuff, but do you know what's relevant to space at this size? Dust grains, micrometers in size. This is literally the size of interstellar dust that is the raw materials of planets and stars. They clump together. Oh, you don't know how big a micrometer is? Well, it's just a bit smaller than a red blood cell, and there are up to 35 trillions of those in your body. Oh yeah, in comparison to Kyle's own goat, he's only this height. You were right about him. So if we were to be running away from a giant 100-meter boulder because I decided he needed to get his steps in, but instead I put that boulder rolling down Mount Everest, that would be quite a funny sight. Anyway, enough of this earthly shit. Let's go to space! You know, visually. In this sensory deprivation tank, where I can imprint the scale's perspective directly into your mind as if you were actually out there. First up, the goddamn Chicxulub asteroid, 10 to 15 kilometers wide. Yeah, this is the evil asteroid that reset our planet and murdered the dinosaurs. But hey, at least it was a tiny one. Relatively. A small asteroid is probably 30 kilometers, and as you can see, that's 2 times the size of Chicxulub. Yeah, I know you could work that out by yourself, Kyle. Good job. Really. I'm sure your date is really impressed. Oh, excuse me, you want to see some real power? Oh, I can show you some real power, baby. A crab pulsar, the dead core of a massive star that is just about 20 kilometers across. Smaller than the asteroid, yeah, but it has the mass of the sun, and 1 teaspoon of it could weigh 1 trillion kilograms. Did I mention that I eat that every day as a cereal for breakfast? Because I do. But even this pulsar isn't as large as a typical 60-kilometer wide black hole that you can get from a 10 solar mass star. And as you'll see, black holes get way bigger, just like I did when I interrupted your date. Anyway, it's time to talk about the solar system. So, the smallest moon is actually Miranda at 470 kilometers wide. This massive round rock belongs to Uranus. No, wait, I wasn't saying that to you, Kyle's date. Damn it, she left. Yeah, don't be mad, Kyle, she wasn't into you anyway. Happens. But, bros before Uranus moons. Right, where were we? Ceres at 940 kilometers across. This is the first object massive enough for gravity to actually pull it into a sphere. Well, sort of. That's the line between a rocky moon, asteroids, piles of stones, and a planet. Well, dwarf planet in this case. Sorry, guy. You're even half the size of Pluto, by the way. And Pluto might be our favorite X-planet. 2,300 kilometers across. And because of this scale comparison, now everyone wants to defend Pluto's size and say, look, it's a planet, Neil deGrasse Tyson. But the next object is the moon, 3,474 kilometers. Yeah, bigger than Pluto. Then we have Mercury, the planet, 4,880 kilometers across, and then Ganymede, the largest moon in the system at 5,268 kilometers across. Huh. So really the lesson is, maybe Mercury should be demoted too. Look at that tiny boy. Indeed, the solar system is bigger than you could possibly imagine, but Mercury is not. Watch this. Mercury, then Venus, then Earth. Mars is really tiny. Jupiter is absolutely massive. Saturn's quite a bit smaller actually. Uranus and Neptune are about the same size. And that's nothing compared to the Sun. We talk about the Sun all the time as some mediocre mid-level yellow but not actually yellow star, but it's still massive. For context, one of the largest planets in the universe, WASP-17b, is 1.99 times the size of Jupiter, and the Sun's 1.4 million kilometer diameter makes it look like that pill I had to swallow after I fell off a Mongolian horse when I was learning to ride him. Turns out he really does love running around as if it's wartime, but hey, it's war. I get it, running is awesome, and death sucks. But I can see you're kinda tired of staying in this tank and only visualizing the sizes of the universe. What say we go 3D for the next level, and I use this device that I just so happen to have here, which makes you get taller, Kyle. Not only would you be tall enough for your date, but we can match the size of anything
in the universe.
Oh shoot, my bad. Wrong button. Here we go. Oh, next it's just a brown dwarf, the most basic form of star. See? A runt. The Sun is huge in comparison. Oh, whoa, here comes Sirius A. 2 times that of the Sun and a lot brighter and a lot hotter. It's an A-type star. All stars scale with temperature and brightness and of course, mass, which means when you see the orange giant here Eta Serpentis at up to 8 times the size of the Sun, 11 million kilometers, you notice. However, not much compares to the massive O-type star Zeta Puppis, 22 million kilometers across. Even the most powerful black hole in the Milky Way, the supermassive beast that powers it, is only slightly bigger. Gosh, I just love Sagittarius A. Perhaps you've heard of Arcturus though, the really large giant star. Yeah, that's a big boy. But the biggest boy is not only you and me, Kyle, as I suddenly stretch your human DNA to the size of stars, but likely WOA G64 at approximately 1,540 times that of the Sun. That's over 2.1 billion kilometers. Did you grunt something, Kyle? Stevenson 218? No, I'm sorry to be the one to tell you this, but its measurements have huge errors. It's most likely not true, and its size goes above the threshold of what's even possible for a star. WOA G64 is currently our best guess for the most massive... Fine. If Stevenson were to exist at that size, it'd be this big in comparison. But more importantly, look, Kyle! The entire solar system? It's bigger than all of these stars. See, Earth is about 150 million kilometers away from the Sun. We call that 1 astronomical unit, or AU, and the solar system is like 200 AU plus across. Think about that. 30 billion kilometers. Well, no stars are bigger than that, and then they explode into supernova and make black holes. You couldn't even see black holes from here. That's how small they are. But of course, they're black holes anyway. But no, Sagittarius is only 4 million times the mass of the Sun, around that. So let's see a 1 billion solar mass black hole. Absolutely stunning at 11.8 billion kilometers across, and that escalated quickly, didn't it? Much like everything I do, including going into extreme debt to fund my crazy lifestyle. Well, used to. That's why I have to put everything in the basement now. Fortunately, as a new bachelor, now I have no one to nag me about fixing that damn tap. I like the constant noise it makes, you know? It's soothing. You know what else is soothing? TON 618, the biggest, we presume, supermassive black hole at the center of a quasar. But here it looks a little naked. Can we make him look a little bit more?
Yes, power.
What? Yes, Kyle, yes, Phoenix A might be even bigger than TON at 100 billion times that of the Sun, but it's also not confirmed at all, like Stevenson. You are a real stickler for hypotheticals today, aren't you? You know, nobody likes a stickler, Kyle. Anyway, it's time to realize that despite these massive, supermassive black holes having more power over the universe than hot French teachers have over students, they aren't actually that big. Unlike our subscribers who no doubt have a massive aura. Subscribe if you want even more. And the objects with the most aura in a galaxy are actually these nebulae. Well, reasonably reproduced nebulae for the viewers. Getting hyper-real ones is a bit tough in this computing economy. In space, nebula can scale to well up over 1,000 light years across and be a breeding ground for new stars. That makes sense when you realize those massive stars from before all die and leave this gas around for new ones to be born, so obviously it's gotta be big, right? And everything we've looked at so far fits into a galaxy, specifically the Milky Way at 100,000 light years. Andromeda doubles down, and ICE 1101 might not be dense, but it reaches perhaps 550,000 light years across, depending on how you define the edge of a galaxy. All galaxies have dark matter halos that are invisible. IC 1101's halo, it could even be up to 6 million light years. By the way, that's nearly 60 quintillion kilometers, which is why we use light years. And as we scale up in space, even light years becomes too much, so we start using parsecs. And 1 parsec is 3.26 light years. Yeah, not the best number. So we'll scrap it. But you just had to know about it, Kyle, because you're literally thousands of parsecs in size now from my amazing device. I can't believe it worked. I actually tested it on that hamster we brought with us around the Milky Way, but it ended up turning him into well, I can't say what happened. It was messy. Turns out he did have the same fate as my childhood pet. Don't worry, I'm sure it's safe for us to keep going up in size, Kyle. Don't worry. As you can see, there are some medium-sized galaxies that are active and shoot out radiation jets the size of, well, Milky Ways. Many Milky Ways. And the thing is, galaxies don't just really exist in isolation. Almost all of them are grouped up by massive dark matter gravitational anomalies. The local group where we live, 134 galaxies, 10 million light years across. And right next to us in this massive space is the Virgo supercluster with potentially thousands of galaxies. Any guesses? That's right, 110 million light years. And yes, all of this is 100% to scale. Now, both Virgo and the local group are part of Laniakea, the supercluster drawn together by the Great Attractor, which is a gravitational anomaly affecting 100,000 plus galaxies, which I hope isn't some higher dimensional gravitational effect, like, something hidden on a nearby universe brain suddenly leaking its pull into our universe, or a large-scale distortion from extra dimensions we can't observe directly that might be communicating with other... Wait, just don't repeat that, I shouldn't have said anything. Wait. Hold on. And so we leave the Laniakea supercluster, Kyle. You missed absolutely nothing. Okay, we are almost there, Kyle. The absolute maximum size possible. One last stop. The largest structure in the entire universe. The Hercules Coriolis Borealis Great Wall. 10 billion light years across. Millions and millions of galaxies and quasars all bound together and interconnected in some way. Absolutely beautiful, isn't it? There's nothing bigger than this, other than the universe itself at 93 billion light years. And we are at the center of it, and literally the size of the Great Wall. Wait, I can't make it smaller again. Holy this is a nightmare. I'm hungry and we can't enlarge food we can't see. Oh, wait, I can. You just can't. Okay, don't worry. I'll fix it. I'm gonna go merge every black hole in the universe.